So in the previous module, the previous notebook, we looked at the generation of musical ideas through random processes, either just completely random or using stochastic models like random walks and Markov chains. Now, we can also generate musical ideas using mathematical concepts like series functions that generate integers or functions that generate particular shapes. In general, we can take any function and map it to a musical idea or a musical content. So for this particular example, I'll also use a couple of functions from another Python library, SciPy, just for the generation of particular sequences. So the first thing that I want to discuss is the use of mathematical functions to generate musical ideas. I'm here introducing an auxiliary MIDI function to generate sequences of MIDI notes that then can be saved as MIDI files that will be used in the following, in some of the examples. So let's start with some functions that generate integers. There are so many. You can, as part of one of the exercises, I'll encourage you to explore different functions of this kind. Here, for example, we have the Pascal triangle. Again, for reference, look at the entries on Pascal's triangle on Wikipedia, for instance. Is basically a function that generates a sequence of integers with particular rules. The rule is actually there using a binomial function. And this is the result that you get. So you can listen to it. It's not particularly exciting. There is no rhythm, for instance. Here is just every note has the same duration. Same thing you can do with the Fibonacci sequence. The Fibonacci sequence is a kind of important series of integers defined by this Italian mathematician Fibonacci. That has actually used also, or has been considered also in many applications in visual arts, for instance. And again, I encourage you to explore the meaning of the Fibonacci sequence in different contexts. Again, we can generate it, and we get this particular sequence here. If you want to listen to it, you just show equal MIDI. So another way of using numerical sequences is by mapping. By mapping means you have a sequence of numbers and you want to map them onto a scale, for instance. And I refer to the lecture for the specific techniques you can use for doing this mapping. This is an example where I take a 2-octave chromatic scale and a sequence of random numbers, and I map one into each other using the formula that is in the PowerPoint. And here we have the, sorry. And here we have the particular results of this mapping. Now, this is a mapping that doesn't have duration, but we can also add duration. And again, I refer to the to the lecture for particular techniques. Here we are using this duration that is defined by the interval between adjacent notes. And again, here is the results now with a particular rhythmic patterns. Again, you can listen to it by playing the MIDI. So as an exercise, I would encourage you to explore different combinations of different sequences. Maybe think about other mapping strategies for pitch and duration, and maybe compose some musical ideas and snippets. Now, of course, in the process of the composition, from a professional point of view, I would say, these are all ideas that you can use in different contexts by themselves. They are not particularly aesthetically meaningful as they are. I mean, it's not particularly interesting just to have this parallelism between what you see in the graph, for instance, and what the pitches do in the musical idea. You can generalize this to any system of data. Here is an example where we use the iris pedal dataset, one of the kind of prototypical datasets for statistical analysis and machine learning and many other things. The advice, the idea, the fundamental concept here is that you need to know your data in order to make some meaningful use of them. So this is another example where we take the data for the length of a petal. These are the three different flower subspecies. We take one of them, we map it, and here it is. So, as I said before, I think, this is not, this is like something that provides you with ideas that have to be used in a creative way. So one example here, this exercise, I would encourage you to make something of this, do something that has a meaningful musical meaning for you as, say, a composer. So we looked at this as data. Now we can combine data with process. And I talk about this, this process in the lecture with different examples, one from Steve Reich, the very famous piece from 1967, Piano Phase, that is actually an example of how process is embedded into these compositional ideas, and the same for a couple of canons from Johann Sebastian Bach and one from Josquin des Prez. So here what we have is the piece, as I discussed it in the lecture, is comprised by a sequence, and this sequence is played by the two sequences that are played by the two hands of the pianist. And these two sequences progressively get out of phase with each other and then back into phase with each other. And this is the evolution of the piece. So the piece is the idea, the foundational idea, the theme is very simple. And here you can listen to it in a phase when both hands play the same notes or play in phase with each other. and so on. You can keep listening if you want, but the idea here is to present the material, and then to this material there is a process that is applied to, and the process is a process of shifting out of phase the two different parts. And this process can also be described programmatically with the piece of software. I mean, you see that the software that defines the in-phase part of the score is very simple. The out of phase is not very much more complicated. The only difference here is that you are stretching the tempo of one of the sequences until you add a note at the end of the cycle, and you keep doing this over and over. So if you run this cell, the program will generate a MIDI file that you can listen to any MIDI player. So speaking of process, and in this sense, in a more general aspect, speaking of algorithmic processes in musical composition, the canon is one of the most common examples. I discussed this also in the lecture. And here I'm showing you two different examples from Johann Sebastian Bach. So you have a single line, a single voice here, and the piece, the composition is just generated using one single operation. That is, you take the theme and you play it reverse. So you apply a retrograde operations to the theme and you obtain the composition, and this is it. In the same way, you can also operate on a single theme. In this example, for instance, in this querendo in Venietis, again from the musical offering of Johann Sebastian Bach, you have a theme. The theme is played, say, straight by one voice and is played by the second voice starting at a specific interval from the beginning, and inverting all the intervals. So if I go from C to D here, I go from B to A here, and so on. And this is, again, an algorithmic process that you can listen to the result here. The last example is this prolation canon from the Agnus Dei of the Missa L'Homme. Here we again have a single theme, and this theme is the duration of the notes of this theme are either decreased or elongated to generate two additional voices, And so you have that the same theme is played with the same pitches, but at different tempos by the three voices. Here, if you run this cell, you again obtain a MIDI file that you can listen to any MIDI player.